Welcome everyone to the video on how we start with scientific notation and we kind of translate that into an expanded form. All right, so what we're always going to do is we're going to start by writing this number out to the side. And then what you do after that is you're just going to follow the directions of the exponent. So notice that this exponent is positive. And so with a positive exponent, we move the decimal to the right. If it was a negative exponent, we'd move that decimal to the left. And then we move it, in this case, 4 places because we have 10 to the 4. So it's a positive number, so we're moving to the right. The number is 4, so we're going to move this decimal 4 places to the right. So I'm a very visual person. Even though I've been doing this for decades, I still physically move the decimal. So I'm going to move it to the right. 1, 2, 3, 4. I like to plant that decimal and put a 0 behind it. And then you fill in these spaces with a 0. So 5.92 times 10 to the 4th is 59,200. And it's okay if you don't put the point zero after. It just, for me, it helps me keep track of where everything is at. But it is also perfectly okay to put a point zero. Same thing. All right, so let's go ahead and do this next one. But before we do, remember, when we have a positive exponent, the number should be big when it's written in expanded form. And 59,200 is a large number. It's greater than 1. Now with number 2, we're going to have a negative exponent. So the number should be less than 1. It should be a small number. All right, so I'm going to move down here. So 3.459. So I'm going to put my pen on the decimal and I'm going to move it to the left 2 places. The negative means left. The 2 tells me 2 spaces to the left. So I'm going to go 1, 2. Plant that 0. Again, I always write the 0 in front of it so I don't get confused. Fill in that missing space. So 3.459 times 10 to the negative 2 is 0.03459. Now, in this case, you do want to put that 0 in front of the decimal. Okay, you never just want to have a decimal starting a number all by itself. All right, number 3, 8.2 is going to be that first part of the scientific notation. So I'm going to plant my pen on that decimal and I'm going to move it to the left 4 places. So 1, 2, 3, 4. Plant that 0. Now fill in the missing spaces. So it equals 0.00082. Now, a way to check yourself once you have your final answer written out is go back and say, okay, if I was trying to take this expanded form and go back to scientific notation, let me change colors real quick, then I would say, okay, where's my first non-zero number? Okay, it would be right here, 8.2. How would I get to that decimal where it wants to be? I would go 1, 2, 3, 4 to the left. So 8.2, and then negative 4 means 4 to the left. So it's just a way to check yourself. All right, I'm actually going to stay in red because I have a lot of blue on the screen. So for number 4, 7.3548, I'm going to take that decimal and move it 3 places to the right. It's a positive exponent, so it's going to go to the right. 1, 2, 3. So 7.3548 times 10 to the 3 is 7354.8. Oops. There we go. All right. 6.1458 times 10 to the negative 1. Negative tells us we're moving to the left, so our number is going to get smaller. We're just moving it 1 place, so we're going to plant it there to the other side of the 6. So 0.61458. All right, last one. So I'm going to rewrite my 1.1. I'm going to plant my pen on that decimal. The exponent is a positive 1, so I'm just going to move it to the right 1 spot. So that's going to equal 11. All right, y'all, please let me know if you have any questions going from scientific notation to expanded form. Have a good day, y'all.